Hey guys, so now we will look at the second problem of CodeStart, that is the digit sum puzzle. It is a slightly tricky problem to comprehend but straightforward once you understand it. Bhavik loves to solve different puzzles in his free time. Some days ago, he came across a series of different numbers called the digit sum series. As Bhavik is busy preparing for the upcoming internship drive, he can't find time for this puzzle. Help him crack this puzzle. The digit sum of a positive integer is a single digit answer which we get after an iterative process of adding the digits. For each successive iteration, we use the result from the previous iteration to find the digit sum. Repeat these steps till you find a single digit integer. Now this seems difficult to understand, but let's try to simplify it. Let's take an example. The digit sum of 7 is 7 because it is a single digit answer. But for 79, we have to add 7 and 9. We get 16. Since it is not a single digit integer, we add them again to get 7. So we can say that the digit sum of 79 is 7. Now this is how we find the digit sum of a single number. Now we look at the digit sum series. A digit sum series consists of numbers having the same digit sum in non-decreasing order. Simply speaking, when we label the numbers in a digit sum series, we go in ascending order. And the distinguishing factor of a digit sum series is that all the numbers in it have the same digit sum. For example, the digit sum series of 1 has the numbers 1, 10, 19, 28 and so on because the sum of their digits comes to 1. Similarly for 2, 3, 4 and so on. Now our task is that we will be given the digit sum value and we have to find the kth term in that digit sum sequence. Let's look at the input values. The first line that we will get will be the number of test cases. The next t lines will contain two integers k and d of xi. If we say that the digit sum value is 1 and we have to find the third term in that series, then the answer will be 19. This is how we have to solve this sum, and we will try a brute force method first. Here we use the function sum of digits to recursively calculate the sum of digits of the number until it becomes a single digit number. For example, we have to find the sum of digits of 79. Here the approach is, if the number n is a single digit number, we return it directly without any calculation because it will be the base case for the recursion. If n is less than 10, it means that it is a single digit number. Otherwise, we have to calculate the sum of digits of n. We initialize this variable sum to 0, and while n is greater than 0, we first remove the last digit of that number using n modulus 10. We add that digit to the sum and we delete the last digit from the sum. In this way, we can calculate the sum of digits. Then we return the sum of digits of the sum, that is, we call this recursive function on the value that we have calculated. For example, if n is 79, then we will calculate the value as 16, and then we will call the function on 16. Again, now n becomes 16. If n is 16, then it will not return 16, it will calculate the sum which gives 7. Then we will call the sum of digits for the number 7. Once n becomes 7, it will be returned directly as it will be the base case for the recursion. Let's look at the driver function, that is the main. Here, the first part is we take input for t test cases, while t minus minus ensures that this runs for exactly t. Well, for this ensures that there will be exactly t number of loops. Here, we are taking the long int value because in the input constraints, it is given that k can go up to 10 raised to 16, which is a very big value. That's why we use the long int data type. Once we have taken the input of these values, we try the brute force method. That is, we iteratively look at all the possible numbers starting from 1. Here we initialize I to 1 and count to 0. We check in which series the number I lies by calculating the sum of its digits. We use the function sum of digits that we defined earlier. If the sum that we calculated is equal to d, it means that I lies in the digit sum series of the number d. Then we can increment the counter variable count because we have to count up to the kth term. And once the counter becomes equal to k, we have found the answer. We can output it and break out of the while loop and move on to the next test case. If it is not equal to d, we move to the next number, that is I plus 1, and check the following. This goes on until we find the answer and we can break out of the loop. Now the problem with this is that it will take too long to calculate, and in a competition environment it will give a time limit exceeded error. So we have to look for a pattern or something to simplify this calculation. Here, if you have noticed that there are only 9 digit sum series from 1 to 9. Here there is 1 and then 10 because the numbers start repeating again. Like 10 is in the series of 1, 11 in the series of 2, and so on. Also, the difference between two successive numbers in any series is always 9. This applies for all series. Here 11 minus 2 is 9, 12 minus 3 is 9, and so on. This means that as the successive differences are the same, it means that this is an arithmetic progression. We can use this property to find the answer in a much more quicker way. We know the arithmetic progression formula for the kth term of a series is a plus n minus 1d. We can use this formula here to directly calculate the answer, which is d plus k minus 1 into 9, because d is the starting value. The smallest number for any digit sum series is that number itself. So a is equal to d. N minus 1 corresponds to k minus 1, and the difference between successive numbers is 9. This is how we can simplify the problem very easily. Now that we have the formula ready, we can run this code. We have passed the sample test cases. Now we have to submit the code to make sure that it runs against all the cases. So this code works. Hope you've understood and it solved all your doubts. Thank you.